As we carry on, our next speaker is Dr. Sidney Shapiro, and he is joining us from the University of Lethbridge, where he's an assistant professor of business analytics in the Dillon School of Business. His work is in applied artificial intelligence, which examines how organizations, communities, and ecosystems use data and emerging technologies to drive innovation, resilience, as well as social impact. But Sidney's focus is to connect academic research with practical knowledge mobilization. And again, that sounds familiar, just like Ardar's focus. So we're really looking forward to your insights. Let's welcome Dr. Shapiro.
All right, good morning. If it wasn't for technology problems, I wouldn't have a job, so this is okay. Hopefully we can get it working in a second. So, good morning, I'm Sidney Shapiro, and we're going to talk about practical ways to use data and AI infrastructure in order to build new pieces. And hopefully we get the computer working. We'll do some live coding. I'll show you some examples of how you could take these tools and build things that are amazing. I think one of the big challenges is that there's tons of hype around AI, and the biggest problem is that it doesn't really translate to value. So we're now, or more recently, in a situation where AI is becoming more and more expensive, and as it does, we're suddenly in this environment where companies have been trying to get us to adopt AI, and suddenly the bill is coming in, because it really doesn't cost $20 a month. It costs a lot more, and then suddenly you want to build things, and it doesn't work great. So thank you very much for Ardar for having me, and hopefully you find something interesting in this that you could take away and start doing the exact same things that we're going to do today and build. So I have some slides. We'll do some live coding. I should tell you that I did a talk like this a week ago in Toronto. It did not work at all. Everything didn't work. The minister says we're among friends, so hopefully you don't hold it against me. I always tell my students, just pretend that you were impressed. Alberta is a fantastic place to build practical tools. And this is for many different reasons. Well, we have the wrong display. How about... There we go. And there's so many areas that are ripe for technological innovation, streaming data, looking at where we could make an impact, and doing things smarter and more cheaply. I'll tell you about a TV studio that I worked with in Vancouver. They do 1 unit of work per hour using some process. Somebody sits on a computer and does this 1 unit of work. And the people called me up and said, "You're not going to believe it. Using ChatGPT, we dropped in all the files, we pressed a button, and now we could do 3 units of work." And that is amazing. Like, ChatGPT AI is dramatically changing what we're able to do. And I said, like, that doesn't make any sense. You bought this computer, it's sitting in your office. You could ask AI to build you a program that runs on your computer that does 1,000 units of work for free. One of my colleagues built a spreadsheet that's been used for 30 years, millions of times. And that spreadsheet over and over again had this scale of economy. It was free to open for the next 30 years. If we're relying on an AI process that's cost money every single time that we're running something, then we really quickly run into the situation where it becomes too expensive and impractical to use. So I think that there's some areas where AI really works well, and things where maybe it's not such a good fit, even though it's a really cool technology. I always tell people, you're not Google. Your job is to find value, not to build cool new technology. Google could afford losing money on cool technology. It's really about finding patterns and thinking about how can we use the computer to leverage those patterns into making better decisions. Like Darcy said, for the past 20 years, we've been collecting data at huge volumes. And suddenly we're like, what do we do with this data? How do we translate the data into value? And that's where this is really coming through with AI that can sift through massive amounts of data, build you a program, and help you figure that out. So, it's important to understand what AI can do, make sure that it's right, and put the pieces together that you're able to build something useful, and we'll work on that today. Now, I did a talk with the PGA looking at building potato apps, and we built an app. The agronomist looks at it and says, none of these numbers make sense. Like, this doesn't, it looks nice and it kind of works. Really, you have to leverage domain expertise, knowledge from the field, trying to bring in pieces of industry into what you're trying to do with AI. So AI is not a magic panacea that replaces your brain. In fact, it could help you leverage the things that you actually know and looking at processes that make sense in order to build, not wholesale replace you, and that's not realistic. So I hear a lot, usually the conversation starts with Terminators, but usually I hear about, this idea of how we could start leveraging technology. This is a critical element of it, taking your expertise and using new tools to build sustainable, cost-effective tools that impact ROI. And that's really the takeaway. So when we look at these messy patterns that we have in data, we're trying to do a few different things. We could look at things like prediction, like with yield, disease, and demand, classification, weed versus crops, green on green, et cetera, and optimization. But AI can't replace clear goals, good measurements, human accountability. In fact, I'll tell you, and thank you for Ardar for inviting me, but I wouldn't have been here had my ChatGPT prompt that said, tell me how to make a huge amount of money, worked. I'd be on an island somewhere, but here we are. Here you all are. Yeah, apparently it doesn't work like that. And the challenge is that it's like, okay, so a lot of students come to my classes and tell me they want to build trading bots using AI to trade on the stock market. And that sounds great. There's only one small problem. Why is your bot smarter or better than anybody else's? You have to know about finance and markets and trading. But they're like, no, I don't know anything. I'm not going to learn that. I'm just going to build the bot. Everybody's doing that. Everybody has a bot. Everybody's bot is trading against everybody else's bot, and nobody wins. So you really have to think about how do you take your context and turn that into an app in a way that makes sense. In AI right now, there's many new things that are happening, like multimodal AI. So you could take a picture, you could walk around with a video camera and say, what am I looking at? And it will tell you. You could have longer context, bigger windows of information it's able to understand. So it's important to know that AI models, in large language models, although they have access to billions of books, they can only hold a few hundred in memory at any one time, a few hundred pages. It's getting a little longer, but they're still not that intelligent. We now have agents and agent workflows that can do things for you, and they can go off and you do a goal, and they'll try to accomplish it. And we also have smaller models, Edge AI, which is more cost-effective, and they can actually do really small things. And we're going to talk about, we could also have better computer vision. Now, I tried this because, I never changed the oil on my car, and I figured this is a rite of passage, and I have no idea what I'm doing. So I took a picture of my car, and I told ChatGPT, what do I do? And it said, go to Canadian Tire, here's a list of stuff to buy, no problem. So I got under my car, all the things purchased, and I said, what's next? And they said, turn that bolt. And I was like, are you 100% sure? And they're like, no, that's actually the steering fluid bolt. You do not want to turn that one. You're looking for the oil pan bolt. I'm like, my feet are pointing to the front of the car. I'm under the car. What do I do next? And it says, look for a bolt. It should be the oil pan. So this problem of connecting real-world data through a sensor, which in this case is the camera, to actual knowledge doesn't come from what works best for most people. I want to know what works for my actual car. What works in my particular context? And that can be really difficult if it has no idea what's going on. Last year we worked on research and we were wondering why people are typing into search engines, chats, etc. Why is my kid crying? And AI will tell you a really nice reason why your kid is crying. But of course, the context part is, how old is your kid? Your kid could be 30. You're probably not going to burp them. I hope not. But you see the point. The point is that it has to understand your context to be effective. It has to actually know your car and know which bolt to turn. And if it doesn't, you're going to get great advice. And if you told it, wait, I just turned the wrong bolt, what do I do now? It's going to say, I'm sorry, you're right, I was wrong. That doesn't help you. So you got to really figure out, how do I align this in the real world to make it make sense? We see these three trends that are happening now with generative AI, where we can create text and images, create nice passages of text which sound very confident but may be wrong. Predictive machine learning, where we could use patterns that we've had in the past and use those for what's happening in the future. Like, for example, when do I maintain my vehicle? How often do I do it? And that gives you numbers that you could build on a risk curve. You have things like yield, disease risk, and so on. The problem is that if you're feeding bad data into your system, of course, the answer is not going to make any sense. And then finally, this turns into control and robotics. So you could do things like steering, spraying, sorting, and many others, right? You could extend this from the beginning all the way into a factory and look at all the ways that robotics and machinery work now. I was recently at the Google conference in California. I went into a Tesla dealership and I saw the robot. You know, the robot, humanoid robot that's supposed to replace all of us. I was not impressed. And you know, I was standing there like looking at it, I was like, this is interesting. Like this is like the first humanoid robot I've ever seen. And 3 really big weightlifting guys came out of the gym and they go, that guy can't lift, you know? So, and I think the challenge is it really depends how and what context we use these things. Now, there's a lot of talk around data centers where AI is stored. Right now, AI is a gigantic sledgehammer that has trillions of pieces of information about it. For example, it knows everything about penguins. There's probably no reason that your farm application has to know about penguins, I assume. And it means that instead of using a massive data center to run that AI, you could use a teeny tiny device on the device, an AI model, that only knows 2 things. It knows the difference between a weed and a grass, and it can tell the difference, and it can show you, using a picture, it can understand the difference. Those small AI models are based on chips that currently don't really exist, although there's more and more being created. Right now, you know, AI, the whole AI revolution, is a software thing. It's not a hardware thing yet. And companies are struggling to keep up and build more hardware to accommodate the massive demand that's come out of this. So we're going to see more and more of this happen, tiny on-device AI. For example, you can go to your microwave and say, baked potato, and it knows what that means. It knows how many minutes. It does not know about penguins. I hope not. Using the largest tools in the world to solve small problems doesn't really make sense. And that's one of the things that's going to change. So as we see on-chip versus data centers, this really makes a big change. But where does AI actually work? Where do we see that? In things like sensors, cleaning data, modeling data, making recommendations, deciding and acting and learning. And all of these different phases involve different types of data coming in and different processes, whether it's AI or machine learning or something else, happening on the other side. So really, when we see this as a workflow, it comes from collect sensing data, predict what's going to happen with that data, make a decision, and act. And the question is, which one of these elements are you handing over to autonomy? Are you telling your robot, here's the answer, go and do this? And which ones are you thinking about first and saying, do these numbers actually make sense? Is this what we should do? Having a human in the loop to approve these automated processes. So right now, we see that AI is good in things like pattern recognition, prioritizing what to inspect, summarizing notes, building calculators, scenario planning. AI is not very good at math generally, generative AI. That uses a different process called compute. So you really need to think about, is this doing math? And if it is, maybe the answers are wrong. On the other side, doing things like diagnosis, automated machinery, poor quality data that it just accepts as the truth, of course, is going to have very terrible answers. I think the really important thing is that you need to start with a costly decision and then ask whether the data, automation, or AI can make it easier, cheaper, or better documented, or some kind of improvement. You always want to say, like, here's our target KPI. This process is going to help that. And if it doesn't, why are you doing it? Google has the money to burn to figure these things out. You should actually work on things that deliver real value. So I'm going to show you a couple examples in irrigation, in machine vision, and with weather. But I think all of them are about building tools that you could actually use, put on your phone, and you can make them work. And if we look at maturity, we see this a spectrum of we could do things like, I want to build a program that grabs records or does irrigation calculators or storage alerts. Those are easy things to do, as opposed to cattle monitoring, crop triage, spot spraying can be much more complicated. And on the other side, like automated drone everything, even more complicated still. So we really have to think about what level of technology, what are all the interoperable pieces, and how can we make it work in a sustainable way. The real takeaway here is that bad data yields terrible results. So if a sensor is broken, or you're feeding bad data into the system, or you've collected 20 years of bad data and you're trying to predict what happens next, of course there's going to be huge problems because the pattern that you put in doesn't make any sense. So it really comes down to finding that decision. What are you trying to do? Listing the key factors and putting together a simple prompt like we'll do today. And then we're going to do something using a web application. You could put it on your phone and then use that process over and over again. Once you build it once, it's free forever. So you can keep on using it and make it work. And there's different kinds of AI. You have things like assistants, like ChatGPT, that will answer questions. You could have like this type of intern mode where it will draft plans and options and actually think about the job and expand it. And autopilot will just take action. And the problem is that taking action, you really have to understand what's going to happen. Otherwise, it may do things that are unintended. So as we look at this autonomy, it's really a spectrum between assisting, supervised AI, remote, and finally autonomous. And we see this, all the data that we're gathering is coming from sensors. So really the critical part is the sensor data good? Does it make sense? If a sensor's off, does that suddenly feed in bad data that starts creating all these other unintended effects throughout the system? And that's where it becomes really, really critical to have the right sensors, to have processes that say, do these readings make sense? And maybe there is an extreme emergency and the readings do make sense, but usually when they're very off, there might be a problem. And we see this happening in many different ways. For example, when we're looking at using trees or identifying sheep, or the best headline I've ever seen, phone in one hand, beer in the other, moving cows. The ultimate dream, right? And I think that this idea of thinking about, what inputs are important? What are you trying to build? What is the logic of those processes that you do over and over again? Looking at, okay, what output do we want this to be in? How are we going to take this element, this idea, and build into something that we could use, and then add human review to make it make sense? So I thought of an idea. What would be useful if I just had on my phone all the time, and I can get real life data for, like, example, price inputs? So I put together this app that shows a few different inputs. This is all it does. Every day it updates, and it will just show me new prices. I could check my phone 20 times a day. It will constantly load new data every time I open it, right? And maybe that's a starting point to looking at trends, to looking at how things change, to making predictions, and so on. At the absolute simplest point. If I know where the data comes from, it's possible. So what I'm going to show you is called a harness. The one we're going to use today is called Cursor, but there's many other ones like anti-gravity and other AI programs. This particular one was just bought by Elon Musk for $60 billion by SpaceX. And the idea is that it could start building, we're not going to use any technical terms or anything else, it will just put something together. Now, I wrote to ChatGPT and I said, write me a prompt to create a single-page HTML-based irrigation calculator, which includes CSS and JavaScript inside of it, give context around Alberta, include the details I need to create the app, and put it into a paragraph. And then it wrote me a prompt that I could use and feed into my other system. So it actually knew the things that I was going to ask for. Like, for example, it told me about all this other stuff. And of course, before you paste it in, you want to read it and see if it works. So the moment of truth, let's try it. Hopefully this works. This could be terrible. So I'm just going to grab the prompt, and I'm going to open up Cursor. I already have it open on a folder. This is called Ardar, and I paste it in, and it's going to think about it. Obviously, it didn't work. All right, one second. Let's try that again. Here we go. It's thinking, and it says, okay, I understand what you want. Let's look at things like soil moisture. We'll figure out our formula. We'll look at clay and loam textures. We'll look at gross irrigation. And this started from my original prompt, and it's putting together this Alberta irrigation calculator that we'll take a look at in just a second. So as we're going, it's gathering all this data. It's thinking about what it's trying to put together, and right now it's writing the code. So we'll see that come out in a second. While this is doing its thing, you can take a look at the one that I built. So I put this in, and again, this doesn't use, hold on, here we go. All right, so this one doesn't use AI. It's created with AI. On the left, you have inputs that you could put in on your iPad. On the right, it shows you charts, dashboard, and you could use this as a calculator that's specifically designed for your specific use case. So you're able to customize this, and this was like a 1-second prompt. You put it in, and a minute later, you get the output. Let's take a look and see if it worked. Apparently, it's still thinking. It really works, I promise. Yeah, not embarrassing at all. It also requires internet, so we'll see if that works. Oh, here it goes. It's thinking. All right. Okay. Let's move on, but we'll come back to it. So there's this idea that there's these two concepts, automation and artificial intelligence. And automation often follows simple rules. Like, for example, in the stock market, you could have systems that say that have been around since the 70s. You know, if this price goes to this, then automatically do that. But we can create many more pathways with artificial intelligence that are much more complicated and much more nuanced to build real, complex, interesting elements that we can put together. So let's do this thought experiment, and we'll go to describe an apple, right? Like, what is an apple? How do we make that work? Do you have any idea? I'm sure many of you are probably going to say something like red or round or whatever. And here's the problem. The problem is that if we defined rules for everything and we tried to match based on those criteria, not only would we have an enormous amount of edge cases, like, for example, the sun is also round, it's also red, an orange is also round, and so on, right? It would take so long to build the rules for everything. What we end up doing instead is just creating different buckets where we could say, okay, I know that it's not an orange, but I also know that it's kind of looking like an apple. With millions of examples of apples and oranges, machine learning can look at those differences. Not because it knows what an apple or an orange is, because it knows that it fits into a particular criteria. And we could see that happening here, where we have the difference between a model that's trained on a healthy leaf, nutrient deficient, pest damage, and disease, and then we train the model to recognize those categories and feed in a completely brand new leaf it's never seen before. And it says, okay, I think that it's diseased because it most closely fits in the world of images of this particular model, right? So we're able to build very fancy machine vision, machine learning models that we can train with other real examples in the past to predict new ones in the future that it's never seen before. And to do this, we have our data that we've gathered and labeled, and it could be historical data as well. And then we could take that data and start to break it apart and say, okay, so if this pattern holds true over a lot of data, then we could build machines that could help us sort the data in a predictable pattern or build those pieces. And here's the idea, where we have the classification system that's trained on the difference between tomatoes and cucumbers. It knows what to do, and then we could start getting to processes where the computer or the machine could decide what to do in what application. Does that make sense? Right? So we could decide what we can do as we go through each part. But here's the problem, that sometimes computers are wrong. This is a very famous example, and I don't know how many of you eat muffins, but I would not want to eat a Chihuahua by accident. And of course, if your vehicle is doing this, that could be an incredibly big problem, right? So we have our irrigation calculator. It says it's done. So let's take a look at what it came up with. All right, so here's the page. It gives you field and crop. It tells you which ones you want to pick. Field area, soil moisture, water balance inputs.
Not showing it on the screen.
Oh, thank you. It was amazing for me. Hold on. All right. How about that? Okay. Perfect. So here's what it built. It put together the context. You could see that it has drop-downs for different types of crops. You could put in the area. You could put in the type of soil and moisture, water balance inputs, and calculate irrigation needs. And you take a look at the output and say, okay, this may not make sense. In fact, it even put in a disclaimer at the bottom, and it says, not a substitute for soil tests, district water orders, or professional agronomic advice. Verify allocations first, Very practical advice. But this tells you its assumptions, and you can go through these and say, okay, there's a problem or something's wrong, fix it, and it will go back in an iterative cycle until it gets better and better, and you have the product that you're actually looking for. And then, once it's done, you could use it 1,000,000 times for free. You have this scale of economy where you're able to use it over and over again. So here's an example with cows. So you could build a cow dashboard that takes a look at-risk cows. It understands what's going on. It's able to look at temperature as well as many other factors. It could do things like gait analysis, where you can see how each cow is walking, and it reports back what exactly is going on. And this technology exists. It's real. OneCup built something similar to this using machine vision, where you could do the same thing with hands. And I saw a project recently where somebody's working in a dangerous environment and they don't have free hands to do things, so they created a bot that looks at them on the camera, and whenever you go like a special hand signal, the machine opens or the gate opens or it does something, and you could control it using your hand, right? Something that you wouldn't have to reach out and touch something when your hands are full. That doesn't make sense, but something like that, you get the idea. So you could do all these different types of things using machine vision. And here's some examples. Whether it's soccer or recognizing bananas or recognizing cars, models can be trained on all different kinds of things. And here's an example in a factory where the person's loading the box, but they're loading the box properly, but they're loading it in an incorrect way. So we could have this chain of logic that says, okay, so we'll let you into the site, but are you wearing a hard hat, safety vest, etc.? And if you're not, what is the remediation? Like, for example, locking the door until you have it. And we see this kind of technology being used in many different areas, whether it's used for inspection or guiding or gauging, or looking at the same kind of thing of recognition and then trying to figure out, okay, what does this look like when it's normal versus what does this look like when there's a problem? So I decided to put this to a test. Let's see if it works. And I built an app. You can try it. Just take a picture. So when you do, you should get my machine vision model. And if you click the screen, you'll see your picture. And if you click the screen, it should take a picture that you could send to somebody. And I think it also puts a cowboy hat on you, if I'm not mistaken. I don't know. It was a while ago I made this, and hopefully it works. We'll see what happens. So just point it at somebody, take a picture, and then you get a cowboy hat, I hope. Did it work? Taking a long time. It has to load a machine vision model on your phone that recognizes people. So basically, it's loading right now what person versus non-person looks at. The last conference I did this, people walked around and said, wait, you're not a person. What is this 22% person like? I got rid of that just in case. But, hopefully it works. So did it work for some of you? It worked? Amazing. You see, there you go. And you can even change hats. This is a full service model. That's right. Okay, we'll move on, but you get the idea. I built this, by the way, in 20 seconds, so you can do the same. This idea in the past is that, this is a Lely-Victor system with cattle, but the idea is that the more data we have, the better it is. But the problem is that having more data doesn't equal good data, it just equals more data. So if you're not able to do anything with it, it's a real problem. And because of changing labor dynamics, and the idea is that we're trying to leverage new robotics and AI, it's really important to think about, okay, so how can we build systems that actually make sense, that are not super expensive, that are effective and cost effective, and we can actually use in a way that gathers the data but then does something with it. And I'll tell you a story about my TV. I have a Samsung TV in my kitchen, and I was sitting with my computer at the kitchen table, and I said to my computer, hey, can you connect to my TV? And it says, sure thing, and it just did it. And I'm like, wow, that's amazing. I didn't even know that was possible. And I was able to build a custom app that I wake up in the morning and it says, hi, Sidney, just like Iron Man. And how are you doing today? It's raining outside, you need an umbrella, things like that. And I just did it in 2 seconds because my computer was able to connect to my TV. I had no idea that was even possible. And that's huge when you think about the right to repair, because when you're working with interoperable systems, like Darcy said before, it's a huge challenge to work on the firmware to make things work together, right? To take a new kind of accessory from one company and attach it to a vehicle of another, you have to reprogram it and connect to it. And now that's possible. And that's something that wasn't possible 6 months or a year ago. And I think that's a tremendous change because you're able to connect to the devices you already own, build custom software really quickly, and test it out all within a really, really short amount of time. So using this kind of idea, the things that we're looking at today, linking to PLCs, linking to new kinds of data, connecting across the infrastructure, you're able to do that and start bringing data in and then make sense of it. So it's not just about collecting data, it's also about putting it into a spreadsheet or a format or a web page or something. You can check with your phone and it's telling you sensor live data, and it's basically very cost effective because you only build the program once and you already own the sensors. And we see this data interoperability ecosystem where we have sensors, connections, whether it's coming from services like the weather or the markets or something else. We transform the data and we can clean it, map it, standardize and validate, and then turn it into dashboards or useful tools that we can actually use for things. And this happens in common data formats that many of you are already aware of, things like CSV and JSON and APIs. Those are the language of what the AI models can speak to. So they're able to really quickly transform that. I'll show you another project. This is one I built, and it's called Build a Standalone Single-Page Agriculture Weather for Alberta, Greenfield, no API keys, using a free API key. So we'll do this in a second, but I want you to take a look at it, and you can grab the code and see the one that I built. And I really built this one in 20 seconds. It put together this live weather map that not only shows you the weather of each individual place, and gives you some agriculture indicators and provides you with place information, it also uses Environment Canada weather warnings, and if there's an Environment Weather Canada warning, it will pop up at the top and tell you there's a problem. And that problem we can trace down. Now, this is just a starting point. This is literally 30 seconds of work. My question is, where could you take this next? How can you make this useful in your context, right? And this is just one single web page. And the idea is, if you could take this kind of thing and build it out into something that has new sources of data, new information. For example, you take this app, you cross-reference it with PLC sensors that you already have, you're going to be able to use that information in real time to make decisions based on the weather. And it just goes from there, based on market pricing, based on so many other factors. As long as you have access to the data, you're able to integrate that and cross-reference to make better decisions. So, I think usually at these talks, somebody says to me, well, I don't need an accountant or a doctor anymore. You still need an accountant and a doctor. That's the really important takeaway here. It works great for some things, but you really need human judgment to make it make sense. You have to do things like check numbers because they don't make sense otherwise. So let's do a quick example and we'll try to build this out and see what it comes up with. So I'll create a new HTML page, and I'll just add this to a new chat, and we'll just drop this in. Here. See if that works. Okay. So now it's figuring out what exactly am I supposed to do. So it says, okay, I'm going to try to build this. I'm going to build this first piece. It will look at the last project, and I'll say, okay, I'm starting from the beginning. I don't have anything else. It's going to look for the Government of Canada API for weather, which is free, and it will start pulling in that data. And it did it by itself. I didn't tell it about it. It's going to look for other free weather sources that are available, and it's going to try to figure that out. And it says, okay, I'm going to put this together and build it in this 2.html. So we'll give it a second, and hopefully it works. So it just wrote the HTML, which is like, I don't know, 1,000 lines. And here it is. Right? So very similar to the app that you downloaded on your phone, same underlying instructions. And I think we're moving away from this idea of like prompt engineering, like you have to know a prompt to get a particular output, to really more like recipes. What makes sense? What's a good thing to ask? How to put that together? And using domain knowledge combined with a little bit of technical expertise, you could build amazing tools like this, and this just generated what you have on your phone in just a few seconds. And this one might even have a better 5-day outlook forecast that they put in there, so I'm not sure what I did wrong, but I think that you're able to think of new creative uses, to take that data that you have, to connect to it, to build new apps and put those things together. So I think that as we're looking at new kinds of apps like this, new tools that are very small, easy to use, they're free over time, so you're not really paying for them. This program that I just used, Cursor, costs $20 a month. The other AI programs are basically free or cheap, and as you get into more complicated data wrangling, there's a very small cost to building tools you can use over and over again. So as we look at like where AI can work and what makes sense, In many places in the ecosystem, it's possible to take all the different elements and use them together by streaming data and cross-referencing them. Yes, you can make decisions based on small pieces of data that you have, but once they get larger and more complex and interconnected, then you could start to have real insight and make better decisions based on real data and leverage those pieces together. So thank you very much for having me. And there's the slides if you want them.
Well, Dr. Shapiro, that was really interesting. It kind of just explodes the imagination and the creativity that's out there, and it is possible. But we've got a couple of minutes for questions. I'm guessing there's going to be a ton of them. However, I guess it'll be whoever's the fastest in putting up their hands. Okay, we've got one already, so go ahead.
Yeah, thank you. It's an interesting question. So, the question really is, this AI has all this knowledge but zero context. How do I give it more context to understand what I'm actually doing so it can know? And yeah, you could feed in more and more data. The problem is it only can keep a small amount in its memory at any one time. So I think that's a problem that we have to overcome in the future because the context windows are relatively small. You could have access to the largest library in the world, but only be able to hold in memory 500 pages at a time. So yes, things that it knows about you in those 500 pages, it can make great decisions. But the totality of your life and decisions and everything you know takes up more than 500 pages. So it can access those things. What I find is really helpful is making help files. So instead of doing the same set of prompts over and over again, teaching my AI how to do a PowerPoint, I'll say, create a file called skills that teaches you how to do a PowerPoint. And then every time I do a PowerPoint, I drop it in. I do my CV, and I'll drop this in, or a profile about me, or the information I'm doing, or my research projects, and I'll say, here's a bunch of starting information to give you context. Now come up with a good idea. It's going to be much, much better because it knows where to start from. Thank you.
Great. Okay, well, it looks like we've got another question over here.
Test.
And I think Dr. Dave reminded me last year, we need to say your name and where you're from.
Hi, I'm Todd. I'm from Olds College. Darcy referenced the fact that he has got a lot of rainbow equipment, right? And a long time ago, I used to work for a company called Farmer's Edge, and we used to put a CAN plug in to collect data. So today, with these more generic tools, my assumption is you could take shape files from various pieces, and you could optimize that overall crop production. Is that correct? So you can take a John Deere operations file and put it with a CNH file. You just have to have the domain subject knowledge. Is that correct?
So that is correct, and I'll tell you a crazy story. One of my students who went to a class where we talked about this built an app where you drop in a shape file, you drop in a GeoJSON file, and then it tells you how many pumps you need in order to build a pipeline on that square, and sold it to his company for tens of thousands of dollars. Literally out of my class, I did not get a cut. So having a bot that reads SQL, that understands JSON, that can bring those things together in context is really a game changer because you're able to use that data much more effectively, especially coming off of Edge AI. Thank you.
I think we've got another question towards the back here. We're making Lydia do the 100-yard dash.
Hi, I'm Kristen with Blue Rock Animal Nutrition. I'm just wondering if you could speak a little bit to security and privacy. If you put your data in, where does it go? Is it protected?
Thank you. That's a great question. And this is the first time since the 90s that producers have asked me to build on-farm AI systems, literally sitting in a machine on their farm that they can see with no internet. And when somebody asked me this the first time, I was like, nobody's ever asked me this on-premises hosting. Everything is in the cloud. And I think people are becoming more aware of, like, what do you need? What size model do you need? Maybe you don't need the largest frontier ChatGPT model, and it could be something small that runs on your phone or runs on your premises and so on. Different kinds of AI models and different kinds of licensing packages have different data sharing agreements. If you're using ChatGPT for free, they're training their models in the future on your data, which is not a good place to put confidential information. If you have a corporate package and you're using the fancy version, they say they're not going to train on it, you have to trust them to say that's actually true. Most of us use AI through things like Microsoft Copilot because it's built into Microsoft Office and they give us access to it. And if you have a corporate version of that, they don't train on your data and it's aware of your files and brings those together. So I think really checking which AI model you're using, how they're using your data, and if they're going to train on your data in the future are really critical so you know where your data is being held and if it's just going to come out when somebody else prompts for it.
So if you have those small units you were talking about, is security and privacy better on them because
Oh, yeah,
nobody else can
definitely.
access them?
Yeah, because they sit in your premises, you can see them, and they could be things as simple as a camera that's able to detect between, a leaf and a weed, and the AI model is actually held onside that device, right? So there's a new device from Coral that's a tiny circuit board, and it has an AI model on it, and it's able to do prediction, but only for a couple of very small, specific things, as opposed to everything.
So the overload of data gets down into bite-sized pieces. I think we've got another question in the back there. Go ahead.
Hi, this is Jordan Roberts from University of Alberta. I'm just wondering if you could speak to some of the baseline skills that might assist from getting, your output from a prompt to an actual applet that you can apply.
I think this is a really interesting question because these things are changing. I mean, first of all, you can ask the AI to tell you what you don't know and provide you with a framework of what you should build. So for example, you don't know anything about JavaScript or CSS or web design, or even if apps are possible, but in one prompt, like I did previously when I said, give me a prompt that I can use, it's going to provide a lot of that context that you can edit and figure out. And if you could say, I don't like the look, I want to improve it, it could try iteratively to go out of that stage. So I'm not saying everyone has to become a programmer or a web designer. I think you could take your knowledge and try to figure out, using the tools, what's a framework that works, what makes sense. So I think that's a good place to start. And I think it overcomes this barrier that we have of technological adoption when people are like, it takes a huge amount of programming to understand this. And I find this in my own classes. It's really important for my students to understand what's possible, what are the recipes, does the data sit in the enterprise so they're able to ingest it and do things with it. It's less important that they understand every esoteric detail because the computer can code better than they can. And I think this is the trade-off as we shift to new ways of leveraging AI.
So it's about asking good questions.
Yeah.
That goes back to my journalistic background of being able to ask the questions. The more specific you get, the better answers you get. Good. Okay, we've got, who's going to make it to the questioner first? Woo! Coming up the home stretch. All right, we've got a next question.
Very maybe philosophical question is, where do you see the risk of complacency coming in? Because we as a company have been using AI in several applications, and for probably 12 months now. In some areas, we've seen people getting very complacent, relying on the AI. So how do you combat that?
So that's a really good question. I did a corporate training recently with the CEO and the CFO, and they're sitting at the same table. They both put in the same spreadsheet into their AI model, and one gave a 1-year forecast and one gave a 2-year forecast with the same prompt. One of them is wrong, right? And I think the challenge is that if we're not actually looking at what comes out, does it make sense, before building it into a pipeline, then there's a risk that we're actually integrating bad data that only gets worse as it accelerates. So I think human knowledge, like really taking your knowledge and critically looking at what comes out of it, is really important. AI tends to be very friendly and optimistic and often tell you that you're right when you're wrong, and then later on says, I'm sorry, you were actually right, my bad. And that's something that we really have to overcome. But building this, critically looking at what they're telling you, is a new skill, just like anything else. So I think that we really have to have really core understanding of the fundamentals to see if it makes sense. As of last year, AI was telling people that there's 2 R's in strawberry instead of 3. And if we give up the ability of counting, of doing math and things like that, then we're not able to critically analyze what comes out of it. So I don't think you have to be an expert in programming the same way that you were a year or 2 ago, but you do have to know the recipes and what to ask for. If you build a house and you don't know that it needs plumbing, that's not going to be a great house. It will look fine, but there'll be a serious flaw. And that's what's happening now with AI. People don't know, and you still need to build that domain expertise, but maybe in a different way.
So the importance of proofreading is also
Definitely.
key. Yeah. Okay, we've got time for another question or two. Anybody else? Searching the room. Oh, okay, wow, now we got 2 pop up at once. Okay. We'll pass the microphone down on this one and run the mic around for the other one. So we'll see who gets them. Okay, you got the microphone first. Go ahead. And your name and where you're from.
Yes, Jansen from High River. I wonder, is our technology capable of selecting sick cattle in a feedlot?
So, I mean, that's a good question. I think it really depends on what does sick mean? Like, what does it look like to the computer, and how does it know? And if we think about sensor data in general, like what makes an apple versus an orange, what's good versus bad, sometimes it's really easy to tell, and sometimes it's really complicated. And training a model on something that's complicated either means more and more training, so it has more examples to draw from, or it's really difficult to know. So I think the answer is complicated. It depends. We could use different sensors. We could use like infrared. We could use sensors like temperature. We could use sensors like audio. We could use sensors like video. But yet all of that may or may not work. I read a paper recently about cow noses are like fingerprints, and each one's unique. Why don't we have cow fingerprinting via cow noses? And I was like, hey, that's a great idea. But I'm like, wait, feedlots are not the cleanest places in the world, and you are not going to keep that camera clean enough to actually be able to detect. Like, so that makes sense in theory, but when you actually apply it in the real world, it just doesn't work. So I think that, as we have better models that are better at prediction, maybe if they're trained the right way, they'll have the right answers. But it really depends on high quality data going to the model in order to give you the best results coming out of it. Thank you.
And another question over on this side.
Hi, my name's Melody McKinnon. I'm with Alberta Goat Association. I know this is very basic, but I'm not an IT person. So my understanding with things like ChatGPT and other source AI programs is they can't actually source, say, research information from the last 5 years. Is that correct?
So it's not really correct. It just depends on what tools the particular AI has. So maybe, like a few years ago, every discipline, every field had a paper like, I asked about ChatGPT about geography and it gave me 10 citations that don't exist. But they fixed that problem, and now AI models can do searches. In fact, right now, half the searches that happen on the internet are done by AI models, not by people. So I think they're getting much better at finding real-world grounding, but you also have to look at like what data is it trained on, what does it think that's important, what is it pulling from, and does it make sense? So is it pulling from Lethbridge, Canada when I'm looking for context, or is it pulling from Lethbridge in the UK? And if it's in a different context, it may not actually make sense because it never asked me, and it never verified what was happening. And you can see this, like systems like Root actually are trained on real data. They give you much better informed answers based on context. Right? So I think it just depends, but they are getting much better all the time. And if you prompt them the right way and you build the right workflows, they're able to use real data, like your data, in order to make decisions. If you just leave it really vague and say, make me a spreadsheet, it's not going to know where to pull from or what to do or how to put it together, so you're going to get something that's probably made up. And I think that's a differentiator. Thank you.
Okay, I think I'd entertain one more question. Somebody got a really good, oh, no. No more questions. Okay.
All right.
I'm getting the hand signal. So, but that was just really fascinating. And we've come a long way from Darcy's dad's notebook. And I think it's really fascinating to see how it can be used. And I think, you taking away some of the fear of it makes a big difference. And are you sticking around for a little bit? Okay. So Dr. Shapiro will be around if you'd like to ask him some questions later on. But let's give him a round right now for a great job today.